Okay, lesson 1.6 is graphical transformations. A lot of this will be familiar to what we did in Algebra 2. Because if you remember Algebra 2 last year, it looked different, but what you see at the top of this page is a lot of what we did last year, isn't it? We spent a lot of time, especially first semester, talking about our translations, reflections. We talked about stretches and compressions, I think is the vocabulary word we use there. This book says shrinks, so we're looking at these graphical transformations. Pre-cal, we're going to do a lot of the same, but we'll take it a little bit deeper too. So let's kind of run through the top of our list and just kind of review. Some of this you heard a lot from me last year. Horizontal translations. So when we were shifting the graph left or right, do you remember what I repeated all the time last year? It's going to be plus or minus a number, but it's inside the parentheses, inside the absolute value, inside the square root sign. It's inside with the x, right? So it's there with the x, and I always say left or right, opposite the sign. So you notice it says minus c, and it's right c. It says plus c, and it's left c. Okay, so that's old news there. Vertical translations. The number is not in the parentheses or anything. It is just at the end, and then you go up or down the direction of the sign. So if it's plus c, you go up c. If it's minus c, you go down c. Old news. Okay. Reflections. Okay, so as we talk about reflections here, two of these are old news. One of them is new news. Okay, we talked about a reflection across the x-axis, is the first one here. And across the x-axis, you multiply the whole function by a negative. Across the y-axis, you put a negative in on the x. And I always kind of remember those opposites, that when I reflect across the y, I put my negative on the x. When I reflect across the x, I multiply the whole thing by negative, which means I'm multiplying essentially y by negative. Now, what about a reflection through the origin? We've talked about reflections through the origin, haven't we? And I've kind of compared it to doing an x-axis reflection and a y-axis reflection. Notice what it has here. A reflection through the origin has both negatives. It has the negative f and the negative x, so negative f of x. So that's another type. And then, lastly, stretches and shrinks. Now, are you guys okay with the word shrinks? Realizing that when I say stretches and shrinks, the Algebra 2 book used, I believe, compressions, if I'm not mistaken. Okay, I'll be honest, I use the words interchangeably. So I am hopeful that at this level you guys can realize if I say compressions, if I say shrinks, I'm talking about the same thing there. Now, if you look down here, the bottom one, so okay, we'll come back to that top one here in a moment. The bottom one, the y equals c times f of x, this is what we did last year, okay? These are the vertical shrinking and stretching that we did last year, okay? So this is the old news part, is the vertical. Because if you multiply by a number, then it's going to, if that number is bigger than 1, it's going to stretch it. It's going to stretch it taller, which in effect makes it skinnier. Okay? Then a shrink or a compression is multiplying by a number that is less than 1. Specifically, when we talk about that less than 1, we usually talk about it being less than 1 and bigger than 0, right? Because it's a positive value. And when we have a shrink or a compression, it's going to, it kind of pushes it down, it shrinks it down, which in effect makes it wider. So those are the vertical stretches and shrinks we talked about last year. Old news. Now, guess what? If those are vertical, this top part is horizontal. Okay, and this is the part we're going to work with a little bit today, or this chapter. are the horizontal stretches and shrinks. You will notice the difference is the C value. The constant is in with the X, but specifically it's X divided by C. And so we'll look at some examples, we might not get to until tomorrow, depending on how we do this, but we'll look at some examples and talk about what a horizontal stretch versus shrink means. But what you have to, okay, so horizontally is left to right, yes? And so if we're going to horizontally stretch something, that means it's going to end up being wider. So a horizontal stretch ends up being somewhat equivalent to a vertical shrink because it ends up making it wider, and vice versa. A horizontal shrink is going to make it skinnier, right? Well, in effect, that ends up being similar to a vertical stretch because it's going to be making it taller. And it's the top of the second page of notes that I'll try and make some, some relationships there between them. The vertical is going to be the easier to work with, but we sometimes have to talk about horizontal. Okay, so horizontal stretch, still by a factor of C if C is greater than 1. Horizontal shrink, again, when it's C less than 1, just realize they're always talking about a number between 0 and 1, so a fraction or a decimal. The negatives go with the reflections. Okay. Keynote here to catch. Transformations can be performed in succession, one after another. If the transformation involves stretches, shrinks, or reflections, the order in which the transformations are performed may make a difference. So in those cases, pay close attention to order. Okay. If you reflect something across an axis before shifting it, depending on which direction you shift, things like that can make a difference. And so we'll talk as we go about how to consider those things. Okay? Before I move my notes up, we're going to go ahead and do example 1. Now, you'll notice it says, example 1 says vertical translations. It really should, horizontal got left off there. So example 1 is horizontal vertical translations. Describe how the graph of y equals absolute value x can be transformed to the graph of the given equation. So, notice parent function of y equals absolute value of x. So you're always checking to see, okay, what's that parent function? What is it that we're relating? And then, I don't know that you guys love seeing this, but in math, it says describe. So I'm looking for words here. Thoughts on A?
The translation down for units.
Yep. We know a translation down 4 units is what we said, and we know it goes down because it's adding or subtracting outside the absolute value, so at the end, and so it's going to go up or down the direction of the arrow, or direction of the arrow, direction of the sign. So, translates down 4 units. Bless you. Do me a favor, don't just say down 4. Give me a verb in there, right? I'm not going to be mean enough to say you have to use a complete sentence, but give me a verb at least. Okay, B. Y equals absolute value of x plus 2.
Translate left 2.
Okay, yep. Translates left 2. When it's added or subtracted inside with the x, in this case it's inside the absolute value, it's left or right, opposite the sign, so this is a left 2. So translates left 2 units. Okay. That wasn't too bad, was it? Okay, let's move down and look at the next one. Okay. Give me a moment here. I have to figure out. That's what I have to use. And okay. I know you guys probably can't really tell. I'm trying a different way to do these notes today. I know. This is a problem. How do I? Oh, Mrs. Rogers, what am I doing here? Thought the words would disappear, but they didn't. They came back. Well, my thing is, if I erase all, I think it erases my page, like the imported document.
So just do the hand thing.
I know, but that's annoying. Surely that's not what she does, is it?
She puts on like a bigger.
Yeah, she has like a really, really, really big size of font eraser.
See, why is it not? Okay. Okay, so I will have to do a little more experimenting. I thought I knew what I was doing by transitioning to this option. I can, but I tend to miss stuff then, and it's just annoying. So, okay, well, that was an experiment. Not the way I wanted that experiment to go. Oh well, making progress. I'm still thinking if Ethan watches the video, this will be a much better quality video than Elmo. So, okay. So, here we are writing the equation. Okay, writing the equation of the following translations. So, A, taking the graph, y equals x cubed. So, y equals x cubed is our parent graph. And how do we write that if we have a shift down 3? So, using y equals x cubed, down 3. Thoughts on what that equation looks like?
Y equals x to the power of 3 plus, or I mean, minus 3.
Okay, yep. Y equals x to the power of 3 minus 3. Nothing fancy. It's a up or down, and so you just add or subtract the number on the end. Okay, B.
Y equals x to 3 plus 2.
How'd you say that?
Y equals x cubed plus 2.
Not quite.
In parentheses.
Okay, so notice here we're doing y equals x cubed, and we're going left 2. We have to involve a set of parentheses here, don't we? How do we write that set of parentheses? So everyone's agreeing that there's a plus 2 here, yes? Left 2, plus 2. So y equals x plus 2, and then the cube has to go outside of the parentheses. Okay, so let me let you know just doing y equals x cubed plus 2 and throwing a set of parentheses on it does not work. Okay, because if I don't have to have those parentheses there. That would be the same thing as just having y equals x cubed plus 2. Those are equivalent there, which that means that one is an up to. Okay, so when we talk about having that plus 2 with the x, okay, so inside absolute value, inside a square root. In this case, the function is the cube, so inside the cube is maybe how I should say it. And to do inside the cube, it's x plus 2 quantity cubed. Does that make sense? That's a tricky one. That's a tricky one the first time through. You guys have seen these equations, but to actually write them is a different story. Good? Okay. And C. Shift the graph of y equals x minus 1 cubed. Right 3 units.
Y equals x minus 4, and then the parentheses power 3.
You guys agree? Or are you sitting there saying, why the heck did Craig just say 4? There's no 4 in this problem. So he said x minus 4 cubed, correct? How'd he get there? Do we see how he got there?
He started going right by 1 unit, so he just put
Yeah.
units on
that minus 1 is already in the parentheses. It's already going right 1. So in order to go 3 more, and I don't know which way, you could think minus 3 minus 1 quantity cubed, or you could say minus 1 minus 3. Either way, that minus 3 is going in the parentheses, isn't it? Okay? And so, with that in mind, yes, when you simplify, you should have y equals x minus 4 quantity cubed. Okay. Questions there? My question to you, how's that light blue show up for you? Can you see it? Okay. I guess let me know if there's colors that you can't see and I'll avoid them. But I know when I do things on the Elmo, there were certain color ink pens sometimes, depending on the day, that you guys would be like, oh no, I can't, you know. Especially like back in the back row with Tori, people would be like, no, I can't see that. So, hasn't been as bad this year, but yes, Jacob?
I will say it is harder to see.
The blue is harder to see.
Yeah.
It's not impossible to see, but
I could see myself maybe mistaking that.
If you could turn the notes into like dark mode, that'd be cool.
yeah, and I don't think I can.
That'd be so cool.
I know, I thought about that, but where we have the black background,
Yeah.
yeah, I don't think I can, when I have a file imported, I don't think I can do that. So, again, I'm still learning the tricks of the trade, so, okay, good to know. I guess what I need to do later is walk back there and see what the blue looks like, so. I do usually try, most of the colors I probably stick with then are for the most part probably okay, I'm guessing. Because I usually stick with darker
What does
colors.
yellow look like?
Oh, probably like that. Oh, yeah, that's
Not good? Okay.
kind of like.
Okay, here, let's see. Try the white. Really, guys?
I can see it.
I can see it.
Well, because I happen to cross through the black, is that what? Okay.
Yeah, that's great.
Anyways, you guys are distracting me here. Example 3. I'm not sure we're going to get through all of example 3, but we can at least, we'll see. Okay, so we talked about our translations, right? Moving left and right, moving up and down. Let's talk about reflections. Okay, we have an equation, f of x equals 5x minus 9 over x squared plus 3. We're being asked to write an equation for the reflection. Now, it doesn't specify what reflection. So we're going to practice, and we're going to practice all 3 types, right? We had 3 types of reflections up top. We had x-axis, y-axis, and the origin, right? So we're going to practice. With that in mind, shall we start with the x-axis? And I'm just going to... Really, guys? Here's the problem. You guys had me write in white, and guess what? I'm still writing in white. Like, why can't I see what I'm writing? Okay. Across the x-axis. What do our notes say about across the x-axis? Where's our negative go?
Negatives go right.
Go where?
Never mind.
The negative goes
Negative
around the
F.
whole.
Okay. If you look, I guess this is what I was looking for, and I'm not exactly sure. Okay. It's a negative f of x, according to our notes, right? I'm not sure we are answering the same question. So, a negative f of x, which means I'm taking the whole function and multiplying it by a negative. Now, if that's just 3 terms added together, you're multiplying each term by a negative. In this case, it's a fraction. So I'm going to start off writing it as negative times the fraction, 5x minus 9 over x squared plus 3. Now, the question becomes, and I'm checking to see what I've done with this, how can we write this as a final answer? When we have a negative multiplying into a fraction, what does that multiply by? Or what are my options, I should say? And I technically would say there's 3 options. Okay, we could multiply it into just the denominator. So multiply it by x squared plus 3. Or we could multiply it by just the numerator, which is probably the more typical one. Or the option is, if you keep it right in front of the fraction bar, you could put it out in front of the fraction bar. Now, the thing is, if you slide just up or just down a little bit, it looks like it's that first sign. So what I tend to do is say, okay, let's take this negative and think about it as distributing. And so if we think about it in that sense, then on top, instead of 5x minus 9, it becomes negative 5x and plus 9 over x squared plus 3. The key is what you cannot do is you cannot multiply both top and bottom by a negative. Because if you multiply both the top and bottom by a negative over a negative is a positive, and you have just multiplied by a positive. And I thought we'd get through one more, but I guess that's a no-go.
So you said it's okay if we put it out in front. That's right.
As long as it is directly in front of the fraction bar,
Yeah.
you can put it out front. And that's just where you have to be very careful. But that would be equivalent. Okay? So what we will start with tomorrow is what happens when we multiply across the y-axis. Okay? So we'll pick up there tomorrow across the y-axis, the origin. We'll do some work on the back. Yeah, we got a decent amount of work left to do here. So you can start the homework, but it will not be due until, Wednesday? And that is page 136, 2 through 32 even.